Okay, here we are back with trying to compare our solutions using the chain rule versus the expansion rule. I use the binomial expansion here, which this is the binomial expansion. This is the expansion with a plus b. I divide a as x squared, b is 4. Pascal's triangle, n equals 3. P1 is 1, P2, 3, P4, 1. Substitute that in here. 1x squared to the 0, 4 to the third, 3x squared to the 1, 4 squared, 3 times x squared squared, 4 to the 1, 1, x squared, 3, 4 to the 0. Of course, this equals 1, right? This equals 1. And what we get here is 64 plus 48x squared plus 12x to the 4th plus x squared. Now I could put it in power order. x6 plus 12x to the 4th plus 48x squared plus 64. Okay, so our solution was, well, what we got from the chain rule, y equals x squared plus to the third divided by 6x plus c. We'll put the c down here. So let's replace it with this, x6 plus 12, x fourth plus 48x squared plus 64, and divide that by 6x. So what do you get this? It's plus c. So what do you get here? You get x5 over 6 plus 2x third, dividing out by this, plus 8x plus 60 plus, is that 64?
I believe that's 64, yeah.
So 6 doesn't go into 64. So let's say it's
not evenly. No.
64 over 6, x to the minus 1, right?
Yeah, 10 to 32, whatever.
Plus c. All right, so let's compare our solutions. So what was our solutions before? So this was method 1 and method 2. So we got method 1 was the chain rule, and method 2 was just expansion. And we just gonna compare it, and you're gonna find out that they're not equal. So you got let's see, x5 over 6, method 2, x5 over 6, plus 2x third.
8x.
What do you mean 8x?
Plus 8x.
Oh, yeah.
I'm just helping with the terms.
Plus 8x.
64 over 6, x minus 1.
Plus 64 over 6 over 6, x minus 1, plus c. Now what was the other one? The other one we had, where are you, honey? X fifth over 5. Right, plus 8 thirds. You can see right now that it's not the same. Plus 16. So you see there's something wrong with this method when I don't have an f of x. And what happened is, I can have an f of x equal 1, but then I would have to have a b equal 1, but I didn't. I had a b equals 6x. So there was an extra 6x on there. So these are not equal. So this is the correct one. This is wrong. Okay, so there are some cases when the chain rule fails. Now, if you can expand it, fine. If not, you have to use a sophisticated technique called usually integration by parts, which we don't teach in this class. So hopefully you won't get one of these. I have seen one of these on one of the finals about 3 years ago. I haven't seen it on since, now that they make up more of a departmental final, which they didn't years ago. We're sort of tied into some of the questions, but I don't think we're going to have that. Okay, so let's go on. Trying to get my notes here. I have a paper clip which outlived its usefulness. Okay, now let's see where we are now. Let's do some practical examples, and that's what we're doing. Okay, so we're going to do section 12.2, practical examples. And the first one. Okay, I'm given that the marginal revenue, remember that's dr over dx, equals 600 over the square root of 3x plus 1 plus 2. Now this is very similar. This is similar to number 9 and number 10 on the 2.2 homework. So if you know how to do this, you can do those. Once again, what we have to do is rewrite this. So we're going to rewrite our basic formula. Is 600 over 3x plus 1 to the 1/2 plus 2. I'm going to bring that up to the top. So dr dx equals 600 times 3x plus 1 to the minus 1/2 plus 2. Don't forget the plus 2. So this is going to give me dr equals 600 3x plus 1 to the minus 1/2 plus 2, multiplying both sides by dx. Distribute the dx. To 2 plus 2 dx. And let's take the integrals. We know this is R. This is what we want, our revenue. This is a revenue function. So this one we know is simply 2x, right? But this is a chain. This is a chain rule. So this is a chain rule. So we have to make some definitions. Remember, we need 5 things. A is 600. Okay, U is 3x plus 1. Du dx is 3 equals B. All right. N equals minus 1/2. And f of x is in here somewhere as a 1. If there's no function, f of x becomes a constant. I mean, there could be a 2 there too, but then you just multiply by that, don't worry about it. So anyway, let's substitute. Now we want to plug in the chain rule. Just this part. Don't forget, this stays the same. We have to carry that, so we'll call this equation 1. Right now, I'm working on the chain rule part. So, let's erase this up here. And we're going to plug in y. Wow. Y equals A, which is 600. Plug it into here. Remember, I don't need this anymore. That was from the last time. Get rid of. Okay, 600. U to the minus 1/2 plus 1 over minus 1/2 plus 1. F of x is 1 And B is, what is it?
3.
3. Well, that goes pretty good. I don't have any x's left over, so I will get a good solution. If I had x's left over, then I know it's going to be wrong like the last time. So this is 600. U minus 1/2 plus 2/2. U to the 1/2 divided by 1/2 times 1/3 plus C. And this is going to be, they'll flip that, right? So what happens when I flip that? I should get 1200. What do I? Was that 600? Yes, it was. Okay. So minus 1/2, that is going to be 1200. Wait, this is 1/3. Okay, so what you have here is 600 times 2. You're going to flip that, divided by 3. U is 3x plus 1, correct?
Yeah.
So the 1/2 plus C. So that's going to be 1200 divided by 3, which is 400. Now I have to substitute in equation 1. So let's go back to equation 1. I'll rewrite that here. So equation 1 was Rx equal this, 400, 3x plus 1, 1/2. I only need 1c, so I don't have to worry about it, plus 2x plus c. All right? I believe that gives you the answer. I could write this as 400, the square root, 3x plus 1 plus 2x plus c. Now we want to find the constant. Now, when we have a practical problem, we just can't leave it this way because we might want to solve for some values of x. So, find C. Well, we have to know something else. So I'm going to ask, what else do we know? It's got to be given in the problem. It says when x equals 0, R0 equals 0. That's what they say. So let's go back into here. Okay. So R0 is going to equal 400. The square root, 3 times 0 plus 1 plus 2 times 0 plus c. Now we know R0 equals 0. 400, the square root of 1, which is simply 1, plus c equals 400 plus c. Bring that over there, so c is minus 400. So our original function now is going to be 400, the square root of 3x plus 1 plus 2x minus 400. And this is our original function. Now they want something else in this problem too. Okay, they want to find R when x is 10. So let's go, is it 10 or is it, no, when x is 5, okay. Okay, once again I have the missing eraser because I don't put it back where I should. So let's do this. So we want to find, Find R when x is 10. X is 5. So let's substitute in here. I'll call that equation 2. So substitute in equation 2. You get R of 5 equals 400. The square root of 3 times 5 plus 1 plus 2 times 5 minus 400. So what is R of 5? It's 400. The square root of 16. Amazing how that works.
As if it was planned.
As if it was planned. Okay. So it's 400 times 4 plus 10 minus 400. That's going to be 1600. 1600. So 1610 minus 400 is $1210 when the revenue is, when we sell 5 units. Okay, at x equals 5 units. Because you can do a whole bunch of stuff with this. You can find the critical values. You can find the maximum, minimum. When I'd ask you to do this, because right now we're worried about integrating. Okay, so anyway, that's a practical problem that's very similar to your problems. How are we doing?
Actually, we're over by 2 minutes, I just realized.
Oh, so they didn't get this?
Well, we have it recorded.
Okay.
It's a question of splicing it so that YouTube doesn't yell at us.
All right.
I'm going to end it.
Yeah, let's end it. Oh, geez.